Hello, can everyone hear me? Awesome. Before we get started, can I just ask you guys for your Penn State ID, like the one that they use for your emails? So it'll be like a couple of letters and then like 3 to 4 numbers. And I just need that for attendance purposes so that my boss knows that people actually come to these. Thank you very much. Okie dokie, let's get started. So this week we were talking about starting to take derivatives, essentially. And we were working on sections 2.3, 2.4, and 2.5. And so, honestly, for some reason, lost my page. Sorry. Places I don't need to be are chapter 6. But basically, the best advice I have for you for these chapters, for these sections, is to practice. This is kind of a skill that you just build by using it constantly and just never, like, it takes a ton of practice to get really good at these. There was a Zoom update too. Okie doke. I'm also just going to check to make sure that we're recording. I would like to make sure that there is a recording available. And we are. Sweet. Okay, so why don't we get started in 2.3. And 2.3, we're covering some of the basic rules. Why don't we begin with number 5? So, and of course, stop me if you have any questions or comments or concerns. Number 5, and I am on page 1. I'm on page 140. So we have f of t is equal to 2t cubed minus 3t squared minus 4t. So what are we thinking about this? What do we do when we need to take a derivative and it is a series of like addition and subtraction? Well, we know that the derivative of a sum is going to be the sum of the derivative. We don't actually need to pull out a constant. It would be tough to take a constant out right now. But exactly, we're going to take the derivative of each of these different parts and then add them all together. So for f prime of t, we're going to end up with 6t squared, right? Minus, this is going to be 6t minus, what is the derivative of 4t? 4, yep. So f prime of t is equal to 6t squared minus 6t minus 4. Okie doke. For the purposes of this class, this is a good answer. You don't need to pull out anything to make it simple, like simplify it anymore. This is a good and productive answer. Okie doke. What about, let's try number 8. We have the function h of u is equal to 3u minus 1 u plus 2 times the quantity u plus 2. So what do we have here? What type of function, what type of rule should we use? Step 1, identify what type of rule we need to be using. product rule. We could actually multiply them. That is, both of those are definitely valid ways to do it. To start with, we could use the product rule. So we would identify f of u as being 3u minus 1, and then we would say g of u is equal to u plus 2. But honestly, this is a simple enough function that we could definitely just FOIL them. FOIL them and take the derivative. So we are going to go ahead and use the product rule for the sake of getting some practice with the product rule. So one thing that I always suggest that people do when using a product rule or the quotient rule or anything like that is to very explicitly state what you're doing at all times. Say that I have the function f of u and it is equal to 3u minus 1. Next, I need to find f prime of u. What is f prime of u? It's just going to be 3. Then I have the function g of u, and I'm just calling these f and g because this is what they use in the book, but you can, use whatever function name you want as long as you keep track of them. G of u is going to be equal to u plus 2. What is g prime of u? 1. So this is going to turn out to be a fairly simple problem. We know that our product rule looks like this. Our product rule says that f of g prime is equal to f g prime plus g f prime. So h prime of u is going to be equal to f g prime, or 3u minus 1 times 1 plus f prime, or 3 times g, u plus 2. So h prime of u is equal to 3u minus 1 plus 3u plus 2, or 6u plus 1. Okie doke. Oh, 6, yes. Sorry. Should be plus 6, so this is plus 5 over here. 6 plus 5. Okie doke. Any questions about that? Using the product rule. All right, let's try a couple other problems. Still on 2.3, still on page 140. Let's try to do problem 11. Here we have the function f of r is equal to 5 over r cubed. What is the first thing that you guys would do when you see a problem like this? I, for one, would not want to see r cubed in the denominator. I don't really like how this is set up. It makes it hard for me to work with. I'm not really sure what rule to use when looking at it like this. So I'm going to rewrite it and say that this is actually 5 times r to the negative 3. And this is correct. Do we know how to work with this? We do. So what would f prime of r be? 5 times -3r to the -2. There's one thing missing with this. When we think about the power rule, exactly, it's minus up top, right? So if we have y cubed, this becomes 3y squared. When we have r to the -3, though, it becomes -3 to the -4. We're still subtracting. So this is going to be equal to -15 times r to the -4. Does that make sense? Awesome. Then let's do number 18. Here we have y, which is a function of x, is equal to root x plus x over x squared. So there's a lot to deal with here. What is the first thing that you guys would do? Okay. So we have 3 different strategies. All of these are going to be valid. You could either use the quotient rule and say that here we have f of x and here we have g of x, and then we're going to continue like that. Or you could do what I believe it's Remy suggested, which is turn this into root x plus x times x to the -2, another good strategy. But we're going to use the quotient rule. And I believe what Philip is suggesting is a part of setting this up. So I'm going to just start out by saying that f of x is equal to root x plus x. What is a way that I could write this that is more useful for me? Or rather, how could I write this square root x in a way that I know how to find the derivative of? What is square root x? X to the half power. So this is going to get turned into x to the half plus x. Next, I am going to want to, I'm going to do this over with blue. G of x is equal to x squared. I need g prime of x, which is equal to 2x. And then I need f prime. F prime of x is equal to what? Let's start with saying, what is the derivative of x to the half? 1/2 x to the -1/2 plus 1. Perfect. Okay, so now we need to set this up as a chain rule. We know that the chain rule is of the form, we have f over g prime is equal to g f prime minus f g prime over g squared. So we're going to say we have y prime of x, which is equal to gf prime, so x squared times 1/2 x to the negative 1/2 plus 1 minus f g prime, x to the half plus x times 2x over g squared, which is going to be x to the switch my book here a little bit so that we have space to continue. So a lot of this is just algebra to follow because we want to turn this into something that's a little bit more workable. So I'm going to turn these x to the negative halves back into root x's and put them where they need to be. So this is going to become x squared times 1 over 2 root x plus 1 minus, and then I'm going to say this is 2x root x plus 2x squared over x to the 4th. And then I'm going to say this is x squared over 2 root x plus x squared minus, this is a quantity here, so it's minus 2x root x plus, that's actually probably better to write as 2x to the 3/2. And this is, again, I probably shouldn't have turned this back into roots because that is x to the half. So this becomes minus 2x squared over x to the 4th. Okay, I'll let me squish my book any further, so we're just switching all the way over. Again, 4th. We can see that this is just basically, you know, practicing simplification. What is this? This is 1/2 times x squared divided by x to the 1/2. That is going to be x to the 3/2 because x squared divided by x to the 1/2 is equal to x up to the 2 minus 1/2. So that's kind of our rules of exponents. Then that is plus, that's x squared minus 2x squared, so it's not going to be plus, it's going to be minus x squared. Minus 2x to the 3/2, or x to the 4th. So this is going to be negative 3/2 x to the 3/2 minus x squared over x to the 4th. Unless you guys are seeing any errors. So 4 is going to be 8 over 2. So this is going to be, our final answer is going to be y prime of x is equal to negative 3/2 times x to the minus 5 over 2 minus x to the negative 2. Do we have any questions, comments, or concerns? That was just a lot of simplification. A lot of times, they don't simplify out as easily, but if you can see that it will simplify out, you're going to want to try. So, okay. Let's see. I would like to make sure that we have time to get to the other sections. So I would like to do question 63. And then try to do some from 2.4 and 2.5, if everyone's okay with that. We're on page 141 now, doing question 63. And here we have the equation of motion of a particle is the function st is equal to t cubed minus 3t, where s is in meters and t is in seconds. So next, we need to find the velocity and acceleration functions of t, and then we need to find the acceleration at 2 different points in time. One where it's 2 seconds, and then one where the velocity is 0. Okay, so there's a lot going on here, but first off, does everyone know the relationship between position, which is what we have here as s, velocity, and acceleration? Because this is something that will continue to crop up in this class as an example, because people just kind of expect you to know it. Any ideas? Yes, we are going to start by doing that. I just want to explicitly state, though, that we have a function of position, and we have a function of velocity. And to get that, we need to take their derivative, right? And then, in order to get acceleration, we need to take a derivative. So we can also say that position is the double derivative. Or rather, acceleration is the double derivative of position. Okay? So we need to just make sure that we know that velocity is the derivative of position, acceleration is the derivative of velocity, and we, as we will learn in the future, we will be able to go backwards between these using integration. But that's for later. We'll get there in just a little bit. First, let's just find out quick what these derivatives are. We need velocity, which is, using power, 3t squared minus 3. Computer is yelling at me. And then we have acceleration, which is 6t. So here we have two functions, right? Part B, we need to find the acceleration after 2 seconds. How do we do that? Exactly. T equals 2. So we say A of 2 is equal to 6 times T is equal to 2. So this is 12. If we are looking at meters and seconds as our units for our position, what is the units of our acceleration? Awesome. Okay. Next, we come to the question of acceleration when the velocity is 0. Does anyone have any suggestions about how to start dealing with this? Well, we know that velocity is 0, but acceleration might not be 0. Because think if you have, this is like I don't know if you guys have taken like kinematics, like physics 211 yet. You can have like a ball going up in the air and it looks kind of like a parabola. And so here you start with like a velocity going up. Here the velocity is going to be equal to 0 because you have to go from having a positive velocity to a negative velocity, right? And if this is, you know, velocity versus time, I guess. No, this is position versus time. So here you have a velocity equal to 0. But the whole time acceleration is the gravity of the Earth. So acceleration is going down the whole time, right? It's a very, very bare bones explanation of throwing a ball into the air. But the idea is that you can have a 0 velocity and a non-zero acceleration. So are we plugging 0 into the original equation? Because that would still just give us time is equal to 0. What we want is actually the time when the function v of t is equal to 0. So to do that, we say v of t is equal to 0, velocity is 0, our function is 3t squared minus 3. We add 3 to both sides. So we end up with 3 is equal to 3t squared. Simplify. 1 is equal to t squared. So t squared is equal to, or rather t is equal to plus or minus 1. Plus or minus root 1, but root 1 is 1. Now the next question is it plus 1 or minus 1? Seconds, because we have t in seconds. Plus 1 can't have negative seconds. So the only time in this function when velocity is equal to 0 is when t is equal to 1. So to find the acceleration when velocity is equal to 0, we find the acceleration of t is equal to 1, which turns out to be 6 meters per second. Does that make sense to everybody? This is the type of problem I would be pretty comfortable doing in this section if you're trying to practice like word problems. But again, a lot of these practicing derivatives is just practice, 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 and you'll get good at them eventually. Let's do some derivatives of trig functions. Good times, am I right? Everyone loves a good trig function. Switch this over so we can read my book a little bit better. Let's start with problem 3. Now these are, page I'm on page 150. Problem 3, section 2.4. Basically what happens here is you guys have a lot of rules that you're going to need to remember. For problem 3, we have the function f of x is equal to 3 cotangent x minus 2 cos x. So we know from section 2.3 that we need to find the derivative of cotangent x minus the derivative, or 3 cotangent x, excuse me, minus the derivative of 2 cosine x. Does anyone remember what those rules are? Yes, that is right. Are not quite. We're missing one important thing from the cos one. Missing a negative sign. This is negative sine x. And then for the cotangent, it is indeed negative cosecant squared x. Okay. So now that we have these two rules kind of fresh in our minds, we can divvy this up. These are just constants hanging out on the outside. So this is going to be 3, or rather negative 3 cosecant squared x minus 2 negative sine x. This becomes a plus sine x. Everybody okay with that? Let's next do problem 5. Here we have y is equal to secant theta tan theta. And we need to take this derivative. What pieces of information do we need? First of all, let's identify what our strategy is. How can we take this derivative? What do I have here? I have one type of function multiplied by another type of function. So what rule am I going to want to use from 2.3? Product rule, precisely. If I know I'm using the product rule, I am going to set this up as f of x is equal to, rather, f of theta. This is also theta. F of theta is equal to secant theta. What is f prime of theta based off of our rules? Or rather, what is the derivative of secant theta? Yes. Secant theta times tangent theta. Okay. Next, we have g of theta, which is equal to tan of theta, or tan theta. Then, what is g prime? Yes. It's secant squared x, or theta, rather. Okie doke. So next we need to remind ourselves what the rule is. Our product rule is going to say that if we have the function f of g then the derivative of that function is going to be equal to f prime g plus g prime f. So we would set it up like this. We have y prime of theta is going to be equal to, calling it f prime g, so secant theta tan theta times g, which is tan theta, plus g prime secant squared theta times f, which is secant theta. This gets simplified down into, we have secant times tan, so this is secant theta tan squared theta plus secant times secant, or secant cubed theta. And this is our answer. It's not pretty. It would be very hard to work with if we were doing like a word problem. But this is what we have. Any questions about how I got here? Let's also try number 8. This just is using some variables. So we have the function y of u is equal to u times a cos u plus b cos u. Rows. That's what I was going for. What is the strategy that you guys would use? Yes, I would use the product rule. My initial thought when I saw this was just distribute that u, but that would actually lead us to using the product rule twice, which is just really annoying, as opposed to once. So we're going to break this up into f of u is equal to u. So f prime of u is equal to 1. And then g of u is equal to a cos u plus b cot. You're right, sorry. It's cotangent. Cotangent u. What would my g prime of u then be? I need to know what the derivative of a cos u is, and then of b cotangent u. Yep. For cotangent, it's going to be a negative. The derivative of cotangent x is going to be equal to minus cosecant squared x. So this is going to be minus b cosecant squared u. So now we have our two functions set up in a way that we could do the product rule with them which I will remind you is, doesn't really matter what order you do them, because you're adding, just as long as you make sure that one is f prime and g and the other is g prime and f. So I can swap those and call it g prime f plus f prime g, because we're adding. Order does matter in terms of, no. What I'm kind of saying is that order doesn't matter. Order matters, yes, for the quotient rule because you have a minus sign, but this is the same as saying right? Because we're just adding the two pieces together. So that being said, let's set this up. Here we have y prime of u is equal to f prime 1 times g. I guess I'll write that 1 in there. So give consistency. Times g, which is a cos u plus b cot u, plus g prime, which is negative a sine u minus b cosecant squared u times f, which is u. So we can start simplifying this out. Call this a cosine u plus b cotangent u minus a u sine u minus b u cosecant squared u. And that would be our answer. Any questions, comments, or concerns? U squared. Where would that be? Are you talking about in this AU sine u type situation right here? Yeah, so the idea behind this is that this would be like if I had, instead of sine u, if that was actually u cubed. And then I was able to say this is u cubed times u, right? I would have like one function, and then I would have my other function, and then I could simplify them together and call this u to the fourth. However, because I have sine u, which is going to be some function that is a trig function, and then I also have u over here, I can't just, it would be like, trying to think of a good analogy for this so that it's more visible. But I can't just say that u times sine u is equal to sine of u squared. Because, yeah. If it would be better maybe to like think about when you have trig functions like this, have the parentheses there. I don't generally put them there because it takes a lot of time to write them down with parentheses. But yeah. Note also that this is not the same as, because sine squared u is actually equal to sine u times sine u. So that's just getting familiar with trig functions, which are kind of wonky to begin with, and a lot of times students haven't seen them in a while. So they can be pretty rough. Awesome. Yeah, no problem. Okay. Next, I want us to think about 2.5. I want to make sure we have time to talk about this because the chain rule trips people up every year. And I promise it's not quite that bad, but we do have to think about functions and how they are like structured. And so to do that, we don't need to, actually we can if we want to, but we don't really need to take the derivative. But I want to think about 5 and 6 in section 2.5. I am on page 158. And here we have this function y is equal to root sine x, and this function y is equal to sine root x. And we need to think about what the composite form looks like. What is the inner function? What is the outer function? And I typically set these up as, I wouldn't call that y, I would probably just call it g, because, yeah, we can leave it as y, that's fine. But I would set it up so that I have a function of the form, call it f of g of x, okay? So we have our outer function is our f. We have our inner function is our g. And our inner function is always going to be a function of x, which is our original variable. Outer function we can think about as a function of g. So here I have the function f of g. So that's kind of how I think about breaking down these types of functions, which I think might be confusing to think about in the just like straight out the bat. But once we kind of break down these two functions, I hope it's a little bit clearer. Okay, so for number 5, what would maybe be our inner function, or what would maybe be our outer function? If you think about it, either outside in or inside out. Is x our inner function? Is that function just x? Question is, what is being done to the x in number 5? Like if I were to have x squared, my function would be x squared. And we can think about this, we can kind of identify these. If we think about the product rule, if I had something that looked like x plus 3 times x squared minus 4, I mean, I could distribute, but I know what my two pieces are of the product rule. So for number 5, I have root of sine x. My function is actually not going to be, my inner function is actually going to be that sine x. Okay? And maybe a good way of thinking about that is those problems that we just did, where if I had the function y of x is equal to tan x secant x, and I want to take the product rule of this, I know what my divisions are. I know what my two functions times one another are. I have this function times this function, right? So tan x is a function. I could graph tan x if I wanted to. I could graph the secant of x. I could graph sine of x. Those are like certain functions. So I'm going to say my inner function is g of x is equal to sine of x. What is being done to my inner function? If I were to write y is equal to, or we'll call it f of g, now I have a function. F of g is equal to, I'm going to say root g. Does this make sense, how I just wrote this? I have my outer function, root of g. If I wanted to put in g of x is equal to sine x, I would have my original function back. And that, I think, is kind of how we work through this. Let's try number 6 as well. for number 6, what would my inner function be? The first thing being like done to my variable. Yes, root x. And then I can like put parentheses around this if I want. And then I can go ahead and say f of g is equal to sine of g. So this is how I would start breaking down composite functions. Do you guys want to just go ahead and try a couple more of these, or do you guys want to actually find the derivative of these functions? I think that okay, let's do this. The formula for the chain rule is going to be the derivative of the function f of g of x is equal to the function f prime of g of x times g prime of x, right? So we need to find both f prime of x and g prime. So let's start with number 5. I know what my g of x is, and I know what my f of g is. These are both of the pieces that I need in order to finish this problem. What is f prime of g? Just leave it in terms of g. ½ g to the negative 1/2. Now I have g of x. What is my g prime of x? Back to trig. Negative cos x. Is it negative cos x? If I'm going from cosine to sine, it becomes negative. If I go from sine to cosine, does it become negative? It doesn't. Positive cos x. Okay. Now I can think about it like this. I need to put the derivative of f, so that is 1/2 g to the negative 1/2, and then multiply it by the derivative of g, which is cos x. And the only thing that's left for me to do is, we will try to wrap this up pretty quickly. The only thing that's left for me to do here is going to be to resubstitute g where it belongs. So this becomes 1/2 times g, my original g, right there, hasn't changed, sine x, and that is to the negative 1/2 times g prime, which is cos x. And you can end up writing it as something like y prime is equal to 1/2 root sine x over, or that's denominator and my numerator is cos x. It would look something like this. We do the same type of thing over here. Here we have f prime of g is equal to cos g, something that we decided in question 5. And we know that g prime of x is equal to 1/2 x to the negative 1/2. So we would set it up in the exact same way. We would say we have cos g times 1/2 x to the negative half. I want to sub my original g where it belongs. So I'm going to end up with cos g, or cos of root x times 1/2 root x. And another way that we could just write that out is saying that y prime is equal to cos root x. There are parentheses here. This is, cos is acting upon that root x. When I read it like this, I cannot factor out or cancel out these root x's on the numerator and the denominator. You cannot just have a hanging cosine. If I had just cos and nothing after it, no variable, no number, no nothing, that would be bad. Doesn't exist. So this is going to be our answer. Thoughts, comments, concerns? Exactly. You can't just have a square root just hanging out with nothing under it. If I wrote this down, you would think what goes under that square root? It seems as if we need to be functioning, like this needs to be acting upon something. So if we think of functions like input, output, if cosine is a function, it requires an input in order to spit out an output. So that is kind of how I like to think about the chain rule. What is my g of x? What is my f of g? If I put these back together, will it give me what my original function is? And then start breaking it down like that. I have time to stick around and do a couple more. I have another session starting in a little bit, but if you guys want to do a couple more practice of chain rule, I'd be more than happy to do some of those. 65. Let me scroll to it. Yeah, let's do it. Okay, so if f and g are the functions whose graphs are shown, yeah, have a great day. Then, oofda, they have a lot of like linking to one another. Basically what this is going to have us do, and I'm going to snip it actually. So give me just 1 second. And do that, and do this. Do you guys see that? And if I didn't lose checkbox. 1 second to find the checkbox. Sweet, awesome. Okay, so here, basically what we need to do is break down what they're trying to tell us. Instead of saying u of x, question number 1 is asking us to find u prime of 1. How can we write that in terms of f and g? That's what we care about, right? So instead of u prime of 1, let's just look at the derivative of f of g. Sorry, it's a huge slant. I apologize for that. Don't have an undo button, so that'll erase it. Let's look at the derivative of f of g of 1. These are the same thing. They're just written one in a way that is sorry. 1 in a way that is much more like usable in terms of like the graph that we have. So let's think about not the specific case of 1, but rather if I have u prime of x, what would it end up being? It would end up being, again, the derivative of f of g of x. What would this derivative be? We've broken it down. We're using the language of the chain rule. It's just going to be what the chain rule is. We're going to have f prime of g of x times g prime of x. Does that make sense? Okay, so when I drew that line, I can't do that. So we just need to find out what these two parts are. And if we think back to composite functions, let's start with g prime of x. G prime of x, what is it graphically speaking? It's going to be the line tangent to the curve. We're going to go back to we're looking for u prime of 1. We know that our x is going to be equal to 1. X is equal to 1. So this is going to be g prime of 1. Our most basic understanding of the geographical meaning of a derivative is the line tangent to the curve. It's the instantaneous rate of change. It's the slope of the line tangent to the curve. What is the slope of g when x is equal to 1? Is it 3? I'm just going to say this is delta y over delta x. I know delta y is going to be equal to, that is 1, 2, 3, 4, 5, 6. So negative 6 over, so it's going to be negative, right? So g prime of 1 is going to be equal to negative 3. Okay, so we've done that now. Now, are we going to do the exact same thing for f prime? Instead of just having f prime of x, what do we have? We have f prime of g of x. So our step 1 is going to be saying, what is g of x when x is equal to 1? G of 1, we can use this graph and find exactly what g of 1 is. G of 1 is equal to 3. If g of 1 is equal to 3, we're going 1 here now instead of an x, then we need to find f prime of 3. So when x is equal to not 1 but 3, what is the slope of f? That is down 1 over 4. Did I count that right? 1, 2, 3, 4. Yep. So it's minus 1 over 4. So that is f prime of 3. And we have g prime of 1. Now we need to go back to our original idea, which is I need to multiply f prime of g of 1 times g prime of 1. We have these pieces now. We can call them f prime of g of 1 is f prime of 3, which is minus 1/4, times g prime of 1, which is negative 3. And our answer is going to be 3/4, positive 3/4. And that is going to be equal to this whole thing here, which is what we call u prime of 1. So a lot of substitution, a lot of things to keep track of. My number one piece of advice when doing chain rule problems, whether they look like this or whether they look like any of the other early problems we were doing, is always to just write everything down so that you can go back and you know that g of 1 is equal to 3. So I'm looking at f prime of 3 instead of f prime of g of 1, et cetera, et cetera. So, of course, no problem. Do you want to try to do v of x or w of x, or do you kind of have the hang of it? For sure, for sure. It's my job. Do you guys have any more questions? If not, then I'm probably going to sign off. This video should be up probably today or tomorrow. If it's not, feel free to email me and yell at me. Yes, you too. Have a great weekend. Bye.